All right, ladies and gentlemen, welcome to Fighting for a 5, episode 13, where we go over the document problem number 14. Of course, brought to you by Couch Potato Brands, snack food, and beverages. Try them. All right, so with this problem, we are given a set of data. As you can see, this is quantitative data because we see numerical values, and those numerical values have units, right? We see parts per million. All right, so those are the units, which is a giveaway that what we're looking at is quantitative data. Not only that, if you read the problem, if you read it through, part B at least, they go on to mention that there's a mean lead level in a sample of 4.9 and a standard deviation in the sample of 1.12 parts per million. So these words are giveaways that what we're studying is quantitative data. All right. Just looking ahead, what that's going to mean is if we decide to do some sort of inference analysis, such as a hypothesis test or a confidence interval, that means we are going to have to use the t-distribution. Especially because we are not given the population standard deviation. So we're not given any information about the population parameters. And so since we're analyzing quantitative data without any population info, we are going to use the t-distribution. Anyway, that's looking ahead. Let's start with part A. Part A asks, what proportion of crows in the sample had lead levels that are classified by the biologists as unhealthy? All right, pretty straightforward problem. First of all, it's important to know that there are 23 crows in this sample. And also, what does it mean to be unhealthy? Well, there's a definition here that says biologists classify lead levels greater than 6.0 part per million as unhealthy. So all we have to do is look at our distribution and count how many of the crows were considered unhealthy. And we see we have 1, 2, 3, 4 of the crows. So I'm going to write that information down. Count of crows with lead level above 6.0 parts per million, that was 4. Total number of crows, 23. And so the proportion of unhealthy lead levels, or crows with unhealthy lead levels, is simply 4 over 23, or approximately 0.1739. And that's that. All right, and I think really technically the only work you would have to show is this last line here. They're not very specific, but anytime you're calculating some sort of a proportion, use the P notation or simply write it out in words. That's fine too, but then you should show like your numerator and your denominator. All right, that's part A. Part B. Again, part B was the one that told us the mean lead level of the sample, the standard deviation of the lead level of the sample. And then it goes on to say that we are supposed to construct and interpret a 95% confidence interval for the mean lead level of the crows in this region. A couple of things here. In order to construct a confidence interval, that means we need to go ahead and go through the 4 stages. This is an inference procedure, so we must do plan, justify, show, summarize. I saw a question on the question stream that asked, why do we have to check conditions if it's not explicitly mentioned? And the truth of the matter is it's very rarely going to be explicitly mentioned. But this is why I taught the plan, justify, show, summarize procedure, because very often they won't explicitly state what you have to show, but they will certainly check for these particular things. So in order to cover all your bases, anytime you're doing an inference procedure, such as a confidence interval or a hypothesis test, always go through plan, justify, show, summarize. Okay. That being said, once we construct the confidence interval, we are then also going to interpret the confidence interval. Notice here we're interpreting an interval and not the level, right? A few days ago, we had to interpret the level. These are different. And when we get to it, you'll see how to interpret a confidence interval. All right, so part B, we're gonna start with the plan stage. Since we're studying one population and we're interested in one population mean and we've taken one sample, this is gonna be a one sample T interval, and we're using a 95% confidence level. These are required to be written. I'm next going to define the parameter of interest. And so out of this population, we're interested in estimating the true average lead level in the crows, I should say the crows of the region. All right, so this is what mu represents. And then of course, in order to help approximate mu, we're going to take our sample mean and our sample standard deviation and use those values to build a confidence interval. Now, in order to be able to build a confidence interval, I have to ensure that I'm allowed to use the t distribution. So I have to check conditions. This is not an option. You must do it. All right, so justify. Random representative sample. Well, if you go up to the description of the problem, there is a quote that says, where is it? I know it says it's somewhere. Food. Oh yeah, the levels of a random sample of 23 crows. So I'm quoting what the problem actually tells me is that there was a random sample of 23 crows mentioned. Okay, so that checks off the random representative sample condition, the 10% condition. So we're talking about the number of crows, a population of crows in one region. I think it's pretty safe to say that 23 is less than 10% of all crows in that region. And 3, the nearly normal condition. Like I mentioned in the previous video, if we have a large enough sample size, in other words, if n is greater than 30, the nearly normal condition is automatically met. That doesn't happen here. So in this case, 23 is less than 30. So once that happens, you have to check the sample itself and see that the sample of lead levels, the one sample that you've obtained, is that distributed nearly normal. Well, this distribution that we were given here, the stem and leaf plot, this is the distribution of lead levels of the 23 crows. So it's the distribution of our single sample. And as you can see, it's pretty much unimodal. It's fairly symmetric, and therefore we can say that it is nearly normal. And so what I wrote specifically is, according to the stem and leaf plot, the sample is nearly normal. Unimodal, fairly symmetric. All right, notice that I am using specific evidence from what was given to me. All right, now to the fun part, the show part. So since the conditions are met, my X bars, so the sampling distribution of all possible sample means from this population, will be distributed using the t distribution centered at mu, which is unknown, so I'm just going to leave it as mu. And the standard error will be the standard deviation divided by radical n. Since we don't know the population standard deviation, we are going to approximate using S of x. So that, unfortunately, is an approximation, and that's typically what we have to end up using, and that's fine. That's why we're using the t distribution, because we're approximating so much information. Okay. It is very important to list your degrees of freedom. You could have listed your degrees of freedom as sort of a subscript here, or you could have just explicitly said that degrees of freedom is equal to 22. All right. Now, when we construct a confidence interval, we always center the confidence interval around our observed sample, which is 4.9. Then we're going to add and subtract the margin of error. The margin of error, of course, is your critical point or your critical value times the standard error. All right, so what I have not done yet is calculated T star. I want to show you two different ways of calculating T star. One, by using the calculator. So remember, this is a 95% confidence level, and the degrees of freedom are 22. So using the calculator, if you have this function, you're going to go to second distribution, and you're going to go to inverse T. The area of interest is 0.975, because remember, the 95 refers to the middle area of the T distribution, but we want, in order to get the middle area of the T distribution, T star will be the 97.5th percentile. Degrees of freedom, again, 22. Paste, enter. Calculating, T star is 2.0739. 2.0739, right? Let me just double check. 2.073. Okay, good. And now I just want to show you how to get that using the table as well. So one thing that you may not have been aware of at this point is that for all of these tests, you're going to be given a whole bunch of, and I'm pretty sure I'm positive actually it's the same for your test. You're given a whole bunch of formulas, so like a reference table. But if you go to after the questions, you're given a whole bunch of tables. You're given a Z table. You're given another Z table. So one for, I think, Z scores that are negative and one for Z scores that are positive. And then you're given a T table. And also, if you keep going, this is a chi-squared table, which is not going to be needed by you this year. But anyway, so you probably won't be given it this year. But anyway, what we're interested right now is in the T table. So what we're looking for is the T star value for something that has a 95% confidence level with degrees of freedom 22. And if you take a look at the bottom here, we have a confidence level axis. And so I'm interested in the 95% confidence level. So this guy right here in the middle. And I'm going to go to the degrees of freedom column. And of course, I'm interested in when my degrees of freedom are 22. And where do those columns meet up? But at I don't know, it's not letting me highlight the whole thing. But anyway, you get the idea, 2.074, which is pretty much the number that we put in here. So just wanted to show you the consistency. I'm going to go ahead and just calculate the upper and lower bound now. So I'm going to pause for a moment. All right, welcome back. And the margin of error ended up being around 0.4843. And so our confidence interval has a lower bound of 4.4157 parts per million and an upper bound of 5.3843 parts per million. And that's your confidence interval. And now the interpretation. So when we interpret the interval itself, we are saying, what do these numbers mean? When we interpret the confidence level, we're saying, what does this number mean? Right? So today we're interested in, what do these numbers mean? The interval. So we go on to say that we are 95% confident that the true average lead levels for crows in this region is between 4.4157 parts per million and 5.3843 parts per million. I'm just going to double check one thing. All right, and we're back. And just looking at the scoring guidelines, you'll notice that apparently there's an option to use the raw data rather than just the summary statistics, and that your confidence interval, if you did that, would be approximately the same. So anyway, I just wanted you to know that if you did use the raw data, they do take that into account. But I think that's a lot longer of a process because of the fact that you'd have to type all of this information into one of your lists and go through and calculate the confidence interval. Now, one last thing is I want to show you how to check your work using the calculator, a pretty simple way to check your work using the calculator, and that would be the following way. So if you go to stat, scroll over to tests, what are we doing right now? We are running a one sample t interval. On the calculator, it's just written as a t interval. What do we have? We don't have data. Well, we do, but that would take a long time to enter. We also have stats. We have summary stats. So that's going to be the better way to go here. Remember, my X bar was 4.9. My sample standard deviation is 1.12. Notice I'm not typing in the standard error that we calculated. I'm not typing in 0.2335 here. I'm typing in the sample standard deviation. They will calculate the standard error for you. Sample size was 23, and our confidence level is 0.95. Calculate. And it gives you your confidence interval. And as you can see, that answer is pretty much spot on with what we have. Yeah, it's identical. All right, there you go. All right, ladies and gentlemen, so just remember, anytime you're doing an inference procedure, plan, justify, show, summarize. Hope that made sense. Hope all is well. If you have any questions, please, please, please ask. All right, take care. Bye.